All right, class. In today's lesson, we're going to talk about multiple angle formulas, which is found in section 5.5. Our objectives are to use multiple angle formulas to rewrite and evaluate trigonometric functions. So here are the double angle formulas. So sine 2u is 2 sine u times cosine u. Cosine of 2u, well, it can mean two things. It could be cosine squared u minus sine squared u, or you could kind of finagle that and get the Pythagorean identity out of that, and you can get 2 cosine squared u minus 1, and also 1 minus 2 sine squared u. And then tangent of 2u would be 2 tangent u divided by 1 minus tangent squared u. So cosine actually has 3 different ways that you can approach it, but we'll take a look at those as we approach. So in example 1, if we're supposed to find all the solutions, the first thing we want to do is check to see if we have any double angles. And in this case, we do. Where we have the sine of 2x, we can actually rewrite that. Move that back. So if we want to rewrite just that portion right there, we're going to have 2 cosine of x plus, and then the sine 2x is the same thing as 2 sine x cosine x equal to 0. Okay, on the left-hand side, I hope that you can recognize that there is a greatest common factor of 2 cosine x that we can take out. So if I factor out 2 cosine x, we're left with 1 plus sine x. Okay, since this is as far as we can go factoring, then we are going to set both of these equal to our answer, which is 0. So I have 2 cosine x equal to 0, and then I have 1 plus sine x equal to 0. So solving for the trig function, or solving for x, I would divide both sides by 2. I would get cosine x equal to 0. So we have to ask ourselves, where would cosine be 0? Well, cosine is an x value, and cosine is 0 at pi over 2 and at 3 pi over 2. So x is pi over 2 and 3 pi over 2. Oops. 3 pi over 2. All right, let's look at the second half of the problem. We need to subtract 1 on both sides. You're left with sine x equal to negative 1. So again, we ask ourselves, where is sine negative? Sine is a y value, so where is y negative 1? Well, y is negative 1 at 3 pi over 2. And that's it. Let's take a look at another example, and it's actually our last example. So it says, use the following to find sine 2 theta, cosine 2 theta, and tangent 2 theta. So they give you quite a bit of information at the very beginning. I'm probably going to run out of space. But the thing that I need you to know is the information that they give you initially helps us to set up a triangle and a quadrant. They're telling you that theta falls between 3 pi over 2 and 2 pi. So it's telling you that we're talking about quadrant 4. Oops. And so since we're talking about quadrant 4, let's set up a triangle to reflect that information. So in quadrant 4, if cosine is 5/13, cosine is adjacent over hypotenuse, so the adjacent side is 5. The hypotenuse is 13. If I did Pythagorean theorem, I would find that my last side is 12. Okay, so let's start the process. So sine 2 theta is 2 sine theta cosine theta. Okay, so that would be 2 times sine theta for that triangle is opposite over hypotenuse. So that'd be 12/13, but sine is sine is negative in that quadrant. And then times cosine, cosine is 5/13, and then cosine is positive in that quadrant. If I multiply all the tops and all the bottoms, I'm going to get as an answer negative 120 over 169. And that's your answer. Let me switch colors for the next one. If I want to find cosine of 2 theta, pick any of the 3 options that you can choose, but I'm going to use 2 cosine squared theta minus 1. So cosine squared, remember, would be 5/13 squared minus 1. And I chose that one because cosine is positive here. All right, we need to square the 5/13, so that becomes 25 over 169. So this is 2 times 25 over 169 minus 1. Okay, from there, multiply the tops. So 2 over 1 times 25 over 169 will give me 50 over 169. Minus 1 will give them a common denominator, so that's 169 over 169. And then as the final answer, you'll get negative 119 over 169. The last one, again, I'm going to switch colors. If I want to find tangent of 2 theta, that's the same thing as 2 tan theta over 1 minus tangent squared theta. So that would give me 2 times tangent is opposite over adjacent. So that would be 12 over 5. Tangent is negative in that quadrant. So this would be negative 12/5. Over 1 minus, again, negative 12/5 squared. Okay, so the numerator is going to reduce to, if I think about denominators, that's going to be negative 24 over 5 over 1 minus, if I square that, that's going to be 144 over 25. The denominator needs a common denominator, so that's going to be 25 over 25. I'm running out of space, I just have to write on top of it, sorry. And that would leave me with negative 24 over 25 for the numerator over negative 119 over 25. Still running out of space. We know that when we divide, we're essentially multiplying by the reciprocal, so I'm going to scoot this over. So the top fraction is negative 24 over 25. Divided by the bottom fraction, well, I'm going to change that to multiplying by the reciprocal. The denominator should be negative 25 over 119. The 25s are going to cancel. The negatives are going to cancel as well. So I'm going to be left with 24 over 119. And that's it. Guys, we are done. If you have any questions, again, please be sure to come see me for tutoring.